You should be able to differentiate between the two. When you are talking about velocity, I get the magnitude of this, you deal with that. They are very, very necessary. So especially with the definition, you have to be familiar with it. Okay. And what's the formula for speed? Distance. So in other words, if you want distance in terms of what speed, you can just make the circuit. And then there is something that we also taught. Now when the time approaches 0, what happens to the speed? When the time approaches 0, it implies instantaneous speed. That's a limiting value of the average speed. That's where we have instantaneous speed. So as the time approaches 0, there will be a speed at a certain instance. And that instance is called what? Instantaneous speed. So when as the time approaches 0, and then we are talking about acceleration, then we have instantaneous what? Yeah, paper. We are talking about speed. We are saying that speed is not the distance over time. Right? So we have time here. And we are saying that as the time approaches 0, the average speed approaches a limiting value. So there will be a speed at that instance. Are you getting it? Speed at a particular instance is the same as instantaneous speed. Are you getting it? Speed at a certain instance, instantaneous speed. What you are saying? But we are saying as the time approaches 0. Are you getting it? As the time approaches, that's when we have a limiting value. Then the instantaneous speed. All these things are this. Okay. So in other words, when we say instantaneous speed, what is instantaneous speed? Is the average what? This you can be making small. Instantaneous speed is what? Okay. Musical infinitesimally short time interval. See, let's say swapra negligible. That's why as the time approaching themselves. There's a definition. Okay, now let's consider this very problem. Find the distance traveled. Let's write this. Find the distance traveled in 3 minutes. Find the distance traveled in 3 minutes. So you see, if you want to change 50 kilometers per hour to meters per second, I have told you that every kilo is a represents what? 1,000. So it means it will be 15 times 1,000. And the meter is there already because meter per second. The unit you want to convert it to meter is there. And then per hour means that it is out of what? 1 hour. Are you getting it? And then 1 hour will give you, in seconds will give you what? 3,600. That's 60 by 60. Right? 1 hour in seconds, so not 1 minute in seconds. So you see 1 minute in seconds. 60. Right? 60 seconds, make 1 minute. And now we are looking at 1 hour in seconds, 3,600. So this one will be 3,000 what? 600. So without using tables, this one will give you finally 25 out of 6. Right? And 1 meter per second. But you see, if you want to avoid this stress, the calculator will just give you straight away without passing through this. And it means sometimes, even if you want to go through the same way, the calculator can confirm whether what you are getting is right or wrong. Until I never go in here. Yes, what's now more. Are you getting it? So you just say this. So this is just like it. Okay. My brother, seriously. Let's consider the next one. Please, who is having a problem with the conversion? How to change kilometers per hour to meter per second? No problem. If you want to solve, every kilo means 1,000. So in place of the kilo, if you put 1,000 there, it means you are left with meters. But it will be meter per hour. But we want it to be meter per second. So the hour in seconds is 3,600. And since it's a pair, it is divided That's why we have something like a scope. So out of 63,600 seconds.
And when you multiply this by 3, you not get the same answer.
When you multiply by
25.6 by the time, which is 3.
Oh, no. It means you have to change it. It was in minutes. So you have to change minutes to seconds. This one is meter per second. So what's our meter per second? Are you getting it? Please, thank you very much for prompting us. If the time is in minutes and this one meter per second, the time you have to also check it. That's the other way in which you can do your calculation. So it means 3 minutes in seconds. That will give you
180.
180. Oh, are you sure? 180, yeah. So 180 by this, and it will give you 750 meters. So in kilometers, 0.75. It's just by the way. It all depends on the instruction you have. Maybe leave your answer in kilometers or meter per second. Okay. Next problem. And the second part of the question. Find also the time taken by this body to travel 200 meters at the same speed. So you see the question is quite clear. Find also the time taken by this body to travel 200 meters at the same speed. And what is the speed we are talking about here? 15 kilometers. But you realize that the second part of the problem, we have a distance in meters. That's why it calls for sometimes these things. So, the speed, which is 15 kilometers per hour, you already know that it's the same as what? 25 out of 6 meter per second, for which you can even use your calculator. Okay, and then the distance is what? 200 meters. So finally, the time is giving us the time. Speed is equal to distance. Then
The time is speed over distance.
distance.
Speed.
Hey, yeah, the real.
Speed over distance.
Someone should confirm for us. Speed is equal to distance over time. So what is time?
Time.
Yeah. This one they are basis. So, but if you joke, how old is it? You do over. Yes. 200 out of. Let me tap the safe. So finally, 48. The unit is very, very important. 48 seconds. Because, and please, if you ignore the units, one can't read. Because if you write 48, is it 48 kilogram, 48 milligram, 48 watts? So that's why when you fail to bring the unit, you'll be penalized. You'll not be awarded the final mark. Okay, so this is very fine. Is there any questions so far on this one? So we are looking at speed, distance, time. We realize even if they will bring question on this, it will be much, or it will deal with how to convert one unit to the other. That one will make you work, but straight away, without doing any work, just put down no. So how to convert one unit to the other matters. Kilometers per hour to meter per second. I'm sure that's the way. And then always you have to check the time. Are you getting it? If the time is in minutes, you have to be very careful. It's now, you have to consider all of them. They are very, very important. Okay. Now let's look at displacement, speed and velocity as another caption. I'm going to take about that. Displacement, speed and velocity. Displacement, speed and velocity. Then what is displacement? What is displacement? Okay. Okay. Very good. So when you are defining displacement, the key word, especially the specified direction or particular direction. And in some books they will add from a fixed point. Because you want to even cover a distance, you start from somewhere. Are you getting it? That's why in some they will add from a fixed point. So if I consider here as my fixed point, and I go this way with a specified direction, that's the displacement. But you see, the difference between distance and displacement is that now if I take the distance from here to here, but the displacement, if I specify this direction as positive and then the other one as negative, so that's the only difference. In displacement we consider the direction, but distance, direction is what? Regardless. These are it through. So the distance covered in a specified direction or particular direction. Okay. And then we also have speed. We have already defined that, but that was the formula. What is speed? Speed refers to what? How far an object travels is the same as what? How far an object travels? Oh, how far an object travels? Because some problems they will tell you find how far the object travels. But also, it's not all the program they will tell you to find speed. Find distance. No. They will be making use of some of these things. How far an object travels is the same as what?
Distance.
Distance, thank you. And you know speed is the same as distance over time. Are you getting it? So when they are talking about it, it's whether to how far an object travels in a given time interval. Please have it through. Distance over time. Now it's what's the same distance or the definition how far an object travels in a given time interval. Alright? Okay. And then regardless of what direction we have found because of velocity c. So in speed here, the direction is not taken into consideration. But in velocity, that's the difference. You consider direction. That's why the velocity displacement over time. Please have it through. But you see the speed, you were saying distance over time. But sometimes the displacement can be equal to the distance. It's in a book velocity. In some of the attack and all that, those of you distance or to be short distance over time and all that. Because magnitude of displacement will give you what? To weigh a fundamental magnitude of displacement distance. Are you getting it? And it is true. Even when you are solving it mathematically, and then you have negative value, when you are finding magnitude of something. For instance, if you are finding a magnitude between 2 points, negative, you see, you will be squaring. At the end of it, if they are even positive or whatever, you will get the same results. So even mathematically, it sounds well. That magnitude of displacement will be equal to distance. Please have it through. But displacement, we take the direction into consideration. So we'll be coming there. Okay. Now let's talk about uniform velocity. Uniform velocity is the same as constant velocity. And you have to understand when we say uniform velocity, what does it mean? What is happening to acceleration when you have a uniform velocity? Acceleration is zero. These are the key. Because some of the problems you have to understand all these principles before you can solve. The question specifies uniform velocity. The question might ignore acceleration. Maybe you will be required to use acceleration. So without knowing an instance whereby you have a uniform velocity and the acceleration is zero, look at it, the acceleration away. On some country. So you have to know all these principles. Okay, good. So when you say uniform velocity, let's write something. It means that in terms of speed and direction, what can we say about it? It is true that uniform velocity, it means as zero, we have a zero acceleration. That's it, how they are related. But when you say uniform velocity in terms of speed and time, what will happen? What it means we have uniform velocity or constant velocity. So constant, and then what is that? That's all. I want you to understand. So let's write this one. It means that the body has a constant speed. And also a direction is what? Constant. Sanity. And also a direction is constant. So that is I. It is moving one way along a straight line because it is constant. So one way along a straight line. That is, it is moving one way along a straight line. One way along a straight line. And then I want to draw a straight line for you to see. When you have a straight line like this, you have a standard here. Or when you have a line like this, we regard this direction, the right. Those of you did science, velocity to the right as positive or negative direction. Positive direction. So we regard this direction as positive. And then the one opposite to it as well, negative. So we have velocity. We have this. And sometimes you have to also be familiar with some of these notation. When you want to make use of the arrowhead, when you see one arrow, normally that's what we use to denote velocity. When they are two, then it means what? Acceleration. Good. Acceleration. Are you true? So that's the notation. So when there is a problem and then we are making use of this, when you see one arrow, a line with one arrowhead, velocity. Please, are you true? But when we are two, acceleration. So when we talk about velocity in this direction, so positive velocity. Okay. This is just by the way of positive velocity. Now let's look at some interpretation. When we say a particle is moving with a velocity of 5 meters per second, what does it mean? When we say something is moving with a velocity of 5 meters per second, it means what?
Every 1 second you move.
Very good. So for a second, it will cover a distance of 5 meters. So in other words, when we have 2 seconds, a distance of what? 10 meters. Because 1 second, so 5 meters per second. 1 second, 5 meters per second, meaning what? 1 second. Please, are you through? This is just the basis. Okay, let's proceed. Let's consider this example. A Ghanaian team marched out of a city P. A Ghanaian team marched out of a city P along a straight road. A Ghanaian team marched out of a city P along city P. City the name of the P. Actually, Manchester City. City, a friend of you. I'm from Massey City. My city, a friend City.
City K.
Okay. Along a straight road. Please, are we all there? With a velocity of 120 paces. With a velocity of 120 paces per minute. With a velocity of 120 paces per minute. Meaning, every minute we have 120 paces. Now, what you see? With a velocity of 120 paces per minute, due north. Due what? North. So due north, what is trying to come into play here? What is specified? Direction. Thank you. So you see, it's very, very important to be noting all this. Direction is specified. It means that even if we have something to do with speed and velocity, then it means I have to look at velocity. If it's about distance and displacement, which one involves the displacement? Are you getting it? Good. Because some of them, they will not tell you to find this. No. What? The sort of person, if you understand the question. Okay. Where was the team? Where was the team 70 minutes later? Where was the team 70 minutes later? So a Ghanaian team marched out of the CTP along a straight road with a velocity of 120 paces per minute due north. So you can draw a diagram to represent that. And the mechanism is also sometimes the way you understand the problem, try and draw something to represent it. And yeah, about mass equal, sometimes there will be no mark awarded for you. But when you draw the diagram, it will give you much information. Okay, you are saying that a straight road. So we can make use of what? A straight line in the direction north. Please, are you getting it? With a velocity of 120 paces per minute due north. Where was the team 70 minutes later? So that question, where was the team, represents what? Displacement. You see, we are talking about because the direction was specified. Please, are you through? Very good. Because we have a direction, so we can't talk about distance in this case. Displacement will be appropriate. Okay, and what other information? We have velocity and we have time. 120 paces, let me put something down for you. And then we also have time.
Yeah, this one, do not draw anything.
Oh, draw something. That's to make use of.
So
we say that no, something like that. Now, what was this? 120. This is at least, though the question is not required for any diagram, but when you draw something like this, it's very good. All right, and then the time. What do we have at the time? 70 minutes. So you realize that sometimes, even before you do conversion, you have to check. This one is 120 paces per minute. And you also have the time in minutes. Do you have to do any other conversion again? I have. So 15 one hour converting. All right. Okay. And then, where was the T? So it means that we want to find displacement. So with this information, if you find it difficult to identify that the problem is requiring you to find the displacement, then no problem. Where was it? So displacement. But when you have velocity and time, you can find displacement. And displacement will be velocity times time. In other words, that will give us 120 by 70 because minutes. But at the end of the day, you see the minute will be nullified. So even your displacement here, you can't talk about meters anymore. What are you going to talk about? Paces. So my dear science students, mechanics is a bonus for you. You see, you did dimensions and all that. You remember dimensions? You see, when you are multiplying one quantity by another quantity, sometimes even if you don't know the units, the quantity will be nullified for you to get to. Which of you who did dimensions of a physical quantity? Physics. So you realize displacement in this case, you don't have to talk about meters because we are talking about paces. And then Where was the team 70 minutes later? And displacement, we can't ignore direction. And hence your conclusion also matters. Which are there, but to conclusion also. Okay, so what are we getting as our answer here? 8,100 pieces. Thank you. Good. 8,100 pieces. We are talking about displacement, direction. 8,100 pieces due. No. Perfect science students. And as a perfect mathematician, mechanics students. Wow. Because that's the direction. Please, are you clear? You see, some of these are fundamental. And then, one thing I have noticed about master is that he used to give marks for conclusion. You can't say, oh, we try. And this means that they use mark of that. At least 1 mark will be awarded for you. Alright. Thank you. Now let's look at graphs. Please, any question on what we just saw? Any question on this? Actually, I don't know whether I'm moving fast. I want to prepare you ahead of the class. That's my mission. Because you also get to know more information. And then you can even ask questions alongside. You see, when you go to class unprepared, I am heading. I do not find about it. You don't have any information here. Do you continue where now I have some questions? But if you have something, master can be okay. To be fanboy, you can also raise your concern, right? We are all learning together. Okay. So let's consider this graph. No, graphs. So graphs, let's go. We are going to look at some geometrical interpretations. Some geometrical interpretations here. So write displacements, and then we have time. And please, what name is given to this axis? The friend said. Oh. Is it?
That's why time is
okay. But someone said Caesar. Thank you. Yeah, modified Caesar. Sometimes when you go to the what's your name and you see, as a teacher, you have to build their confidence. You have to do something so that they will be impressed. And yes, sir. Sure. Where I did my internship, the guys, they are smart. Boys school was 82 senior is from Happy. So I told I was also teaching Form 3. When they trust you, you don't have any problem. You see, as a teacher, you can make mistakes. But if you don't have their trust, but the moment they trust you, so sometimes when you go SRS, what is abscess are from hey. Nobody abscess are working. Okay, thank you. Alright. So if we have displacement, and here is what? I like it on it. So now if we draw a straight line here, we can talk about a point on this line. Point in the base, what do you think the point will be in terms of, okay, let me specify my displacement access. So we don't know any value, but we are looking at them in general. And then the time here as t. And we want to specify a point here. Physical coordinate from a base TS. Thank you. Because it will depend on the time you have and then the displacement. But we a general one, so it will be TS. Are you getting it? Now let's look at the second case. We want to find gradient of this line. One graph is being drawn. Graph bend a bow. Yeah, when you say displacement time graph, you are right. You are right. In some of them, they will tell you constant velocity in a positive direction. But over here, we are looking at displacement as against time. What you say? So displacement time graph. Now let's try and find the gradient of this particular line. You ever want to have this sample small one, big one. So now we know our displacement is S. So then we have this one as our T. Then the point here, we are saying the point here is TS. So if you want to find the gradients, send the M. See what you say. Okay, so the formula will be what? Changing S by changing T. Very good. Now that's the gradient. These are we following. And we are getting something. Why name be? What do you think the gradient will give? Yes. You said velocity. Because changing S by changing what? T. So geometrically, draw this one and let me give you the geometrical interpretation of what you have. Geometrically, when you find a gradient from a displacement time graph, you get what? Velocity. Very nice one. A vertical. It is true. So draw the two diagrams and then we give you the interpretation. But I told you this point is what? What name is given to that point? We can adjust a point. It's true. Point here, you can talk about fixed point and a variable point. We have a friend is saying variable because it can change. So it will vary. Please, are you getting this? The demo will be variable point. Good. So mapping, saddle. Okay. Please, are you done with the diagram, drawing of the diagrams? Then let's write this. The geometrical interpretation of the displacement time graph. The geometrical interpretation of the displacement time graph. The geometrical interpretation of the displacement time graph is that the gradient of the path. So we are talking about this, the path we have printed. The gradient of the path formed by the objects. The gradient of the path formed by the objects gives the velocity of the objects. Give the velocity of the objects. Give the velocity of the objects. Give the velocity of the objects. So that's the geometrical interpretation of a displacement time graph. We are not looking at the area in this case because there will be nothing useful. In the area of a displacement time graph, there is nothing useful. But the gradient here, so it will give you the velocity. Alright, I'm saying this because when you get to the velocity, you'll be finding the area. But how you see area now, it's useful mine. But you do velocity, I want the movement. So over here, when you have a displacement time graph and the gradient, it means you are going to get velocity. Because that's a change in S, change in T. And that's velocity. Okay. Let's proceed. Now let's also look at the velocity time graph. The velocity time graph. So draw and write the caption velocity time graph. velocity time graph. Normally, I have a longer distance in the event. You know where I am. Then I'm going to show you the So what do you think if you have, if this one is our velocity multiplied by time, what are we going to get? Displacement. So the area, okay, so draw it and let me give you the interpretation. It is true. And what's the gradient of a horizontal line? Yeah, the T or something like this. Because one master told me someone came for an interview. Sometimes it doesn't matter. You'll be thinking that they'll be asking you Google's question. No, boy. You must have questions can see beyond that. I have it up and you say what is set now to pressure forward. It's not easy. I'm talking about maybe the lecturers. You see, before you can be enrolled into this institution as a lecturer, you have interview and all that. Usha. So when you come and they are interviewing you, some of these basic things. While Professor Opoti told us when we were in level 300, that one mathematics teacher was trying to apply in his institution. He's having a school. Professor Opoti school. Accra, okay. Now he said, you only ask him 6 divided by 0. A number divided by 0 will give you what? And the master says 0. We are in TLC and one on our pond. Kofi, look at this. You see, you can even get first class and then you go there. Did we say? Your marketing is, you see, some of the things. And let me give you this. If you're a student, don't rush in solving problems. Especially when you have a case. If you have a case or friends, KG for any P2 for if you don't take it, they will disgrace you. They will bring the assignment, then they will be on you. My brother will bring who ties you. What do you want, brother? Hey, university near what you want. Ghana is a history. So apply your psychology. That's what I've been doing. Many amount there. I will try and then engage you for you to understand, so that when you will tear say you see, and then you see marking it differ from one teacher to the other. I have followed my auntie is an examiner in WAEC. WAEC. And go for me you go there, even we have team leaders, we have chief examiners. Chief examiners themselves. For instance, if you have a question, if this guy is a chief examiner, you will have a different impression in awarding a mark. When you a chief examiner, also see different. In awarding marks is not the same. How much more you need to work for mark? If you are not lucky, your kid will bring an exercise or homework to you. What is this? Blah blah blah. You write it down. He or she will take it to the school, and the teacher over there will regard it as you didn't give all the nutrient points. After you bar, hey, wabon. Especially in mathematics, relax. Permanent fan send some time be so make sure that at the end of the year wait out. Because teacher need your what being said the other obetino and no. Are you getting it? Well, I don't know what is the meaning of perplex. So this is minimum. See, you are more you're crying for that it's perplex. I won't pray. And it's all about information gathering. We'll be able to get more information here when we are seeing you need help. See, to give you all no man. Now you are here. So gradient of a horizontal line is what? 0. Now people are interviewing you say gradient of a horizontal line. Only I know they are wrong. Went to me and then what is that of a vertical line? Thank you. Hey, won't be on. What's in the way? All right. You now see you good. So be good. Now geometrical interpretation. Right? Geometrical interpretation. Geometrical interpretation. The geometrical interpretation of velocity time graph. The geometrical interpretation of velocity time graph is that the area under the curve gives displacement. And it is true, that's what we are seeing over there. Alright? To give you displacement. To give you displacement.
Is that?
Okay, is that okay? The geometrical interpretation of a velocity time graph is that the area under the curve gives displacement. So now let's okay. So that's just by the way. And then let's discuss this when you need to be an electron. What is acceleration? What does it mean when the body is accelerating? When the body is accelerating, what is happening to the velocity?
Body is what? Accelerating.
Yes. If a body is accelerating, it means what's happening to the velocity?
Increasing.
It's decreasing, it's increasing.
Accelerating.
There is what? Change in what? Velocity. Because the change can either be what? Or decrease. Because we may specify because we have positive acceleration and negative one. Please, are we getting it? Very well, just by the way. So, an object whose velocity is changing is said to be what? Accelerating. Are you a science student? Oh, I like it. Good.
I'm a business.
I'm not just saying you're a business student. No, it doesn't matter. Even I did science, during our time, doctor brought one question on economics. You can chemistry to answer economics. My economics. We do a while, it's all about the mind. Though. If you program your mind, say, hey, anyways, mind, no, it's never true. You shouldn't fear, even if you didn't do science at the SHS level, you can still come back strongly. And found cry. We are in the science and we're feeling now. Okay. And then when you say instantaneous acceleration, what is instantaneous acceleration? There must be instantaneous, because we define instantaneous speed. So instantaneous acceleration. Clearly, what are the answer? Okay, infinitesimally. Yeah, we are not so infinitesimally short time intervals. Now when you are not there, I'm modify strategy in learning. Alright? Okay, so the average acceleration within infinitesimally small time interval. And then when we have a positive acceleration, it means yes, positive acceleration. Very good. Yeah, Seb. Oh, sorry. I'm sorry. I was speaking to you. I'm sorry, okay. But thanks for that. You have to prompt me. Sometimes because it's our local language, we have been in the home. So sometimes when we are talking, it will just pop up. Because it is part and parcel of us. You see, when you come to school, the environment here is different. When you go home, people almost say, hey, look at this. What's inside there? Alright, so I'll try and change gradually. Okay. So positive acceleration means that the body is what? Increasing. That's a key word. And then negative acceleration means the body is what? Now let's try and change the word decreasing or decelerating. Decelerating. Or I like it. Retardation. So when you have a negative acceleration, you can say deceleration or what? Retardation. In other words, you have to be very careful. Positive acceleration. positive acceleration.
Ah,
It means the body is still accelerating and it is increasing. Positive acceleration. Because we can have a negative acceleration. And that's where the body will be what? Decreasing. Which is the same as decelerating or retardation. In other words, if your acceleration is negative and you want to make use of retardation or deceleration, please, you have to be very careful. You can't say acceleration is equal to negative 2 meters per second square, and you come and tell us deceleration is negative 2. Hey. Because this thing, if you are not careful, you will be likely to tempted to do that. If you have negative 4 meters per second square as your acceleration, and if you want to say decelerating is 4 meters per second, because the decelerating itself, you know, is a negative acceleration. It's kind of alright. And then zero acceleration means zero acceleration. Constant what? Velocity. Oh, good. You are clever. Keep it up. It means you are very good in mechanics. That's great. Alright. Now let's consider this problem. A car accelerates. Example. What's the time? What time? Let me. Oh, okay. A car accelerates along a straight road. A car accelerates along a straight road from rest. A car accelerates along a straight road from rest. A car accelerates along a straight road from rest to 75 kilometers per hour. To 75 kilometers per hour in 5 seconds. Yeah. You see? A car accelerates along a straight road from rest to 75 kilometers per hour in 5 seconds. So this one alone, even if the question is not there, at least you should be able to think about something in which the question will ask you to find. Because you have a velocity as against time, what do you think is coming out? Acceleration. Yes. So sometimes you can even think for the question and you realize it will not be there. Alright. What is the magnitude of its average acceleration? What is the magnitude of its average acceleration? What is the magnitude of its average acceleration? And what's the formula for average acceleration? Let me put it down before. So I will give you that, but I know you put something. Average acceleration is the same as yes. This average acceleration is the same as. Oh, I didn't give you that. Okay, I'll come there. Good. And then what's the formula for average speed? Average speed. You see, the distances we don't take the direction hard. Normally say total distance, but those that involve the direction, tick. So when we are talking about changing velocity by changing time, changing displacement over changing time, and the average, that's the clue. Please, are you through? But speed, since the direction is regardless, you only see total distance or total time. So over here, we can say V2 minus what? But the moment we say V2 minus V1, then what will happen to our time? T what? It doesn't mean that when we interchange the position, you get the same. But if your V1 is same, your T1 has to be that. That's why we need the formula Y2 minus Y1 S2. If it is Y1 minus Y2 out of X1 minus X2, you get the same results. So never change. Just that your V2 has to be consistent with your T2. Please, are we through? Wherever you place them, you get the same result. Right? Okay, and then we're saying something like a straight road. We draw something to represent that at least. And then it started from where? From where?
Zero.
From rest. From rest. So the initial velocity is what? Right, then up to 75 kilometers per hour. Alright, but you have to look at something carefully. The time is in what? The time is in seconds. So at least you have to do something about that. Please, are we watching? You can't just do the substitution. Though this question looks very friendly, but if you don't check the units, you can get the answer wrong. The time is in seconds and this one is in kilometers per hour. So the units has to be consistent. If it is kilometers per hour, then R in time. Meter per second, then seconds in time. So it all depends on you. Either you change this one to meter per second, but because this one is zero, that's zero. Every zero is zero. 0 meter per 0 kilometers per hour. So cause no change. But this one is a value, which is value. So the unit you can't ignore. 75 kilometers per hour. So which one should we change? Which one should we change?
Change the R to second.
You should change the time to. Alright. And what are we going to get? So T is 5 seconds and then that's 5. Then they can be reduced to 1. Very good. Please, we shouldn't forget that this one is seconds to R, not seconds to minutes. Seconds to R. So 3,600 seconds. Give me what? An R. Please, I will do. Because I heard 66. Let's look at it. So 1 out of 720. Then we can do the substitution. Over here, our average magnitude of our average acceleration is going to be V2 is 75, and then V1 no change, and then V2 1 out of what? 720. What will happen to the time? Because the value is at rest. Stationary. Okay, so in other words, you get 75 and then 1 out of 720. What's the final answer? Final answer. 54,000.
54,000, yes.
54,000. You know, I have to add another zero, right?
Yes.
Oh, okay.
Acceleration unit.
Average acceleration. So what will be the unit? what will be the unit? Yeah, actually this person, the units. Actually, this one. I think there was something to meter per second square. That's how 27. So I have this one in meter per second.
So kilometers per hour seconds.
But anyway, let's do it.
Hour square.
It's okay. So this one, I don't remember. The question was
This hour.
which one?
But sometimes you have to be in the standard.
The time is in hours, and this one is in hours.
Yes.
Hours will go.
Yeah.
Per time square.
Yeah. The hours will go. Kilometers per hour.
To not go.
Wow. Acceleration, no, else it will cause a change. Just ignore. This problem, there was something, I didn't write it well. It's okay, just by the way.
But the original one should be what?
Which one?
Acceleration is what?
Actually, this one should have been
Like
meter
the
per
unit
second.
for acceleration.
But there's nothing wrong with this. But when you have this, you see the other one meter per second square. So that meaning kilometers per what? Don't see. That's why we even have microsecond and all that. You see, sometimes the popular unit that we use, meter per second, we are friendly with some other units. But we also have microsecond and milli whatever. They are all there. That's the same thing which is happening here. So if you should have changed this one to meter per second, so you'll be getting meter per second square. That one too is there. And right now you can even use the calculator to change 75.
You change it.
So you can leave the answer in meter per second square. That one is friendly. And when you're friendly, if you get kilometers per hour, hey, what am I getting? But it doesn't change anything. Now let's consider another example. Let's consider another example. A particle moving in a straight line. A particle moving in a straight line. A particle moving in a straight line with constant acceleration. With constant acceleration. With constant acceleration of -3 meters per second square. A particle moving in a straight line with constant acceleration of -3 meters per second square has a velocity of 15 meters per second. Has a velocity of 15 meters per second. Full stop. Find its velocity. Let me take it again. A particle moving in a straight line with constant acceleration of -3 meters per second square has a velocity of 15 meters per second. These are all there. Find its velocity. A. 4 seconds later. A. 4 seconds later. 4 seconds